Hello students and welcome to video lesson 8-5. In this video we are going to start taking all of this double distributive property and FOIL method and all that kind of stuff we've been doing over the first half of chapter 8, and we're going to reverse it. Okay, we're going to work on factoring quadratic trinomials into two sets of parentheses, two linear binomials that look like we should then FOIL them out or double distributive property. So what we're going to do first is I would like you just to pause the video for a second and tell me what these three polynomials would equal when we multiply them together. Just a quick review of our double distributive property or FOIL method. So pause the video and let me know what you think these are going to equal, and then we'll come back and I'll show you what they should equal. No, really, I actually want you to pause the video. Pause it. Okay, so when we multiply x plus 4 times x plus 2, we should have gotten x squared plus 6x plus 8. When we multiplied y plus 5 times y plus 8, we should have gotten y squared plus 13y plus 40. And when we multiplied k plus 2 times k minus 3, we should have gotten k squared minus 1k, or just minus k, and then a minus 6. Okay? So hopefully you got those. Hopefully you understand the double distributive property FOIL method, how it works. Well, like I said, what we're going to do today is we're going to take these things and we're going to turn them back into those things. Okay, and here's what I need you guys to notice. I need you to notice that every time we did a double distributive property or a FOIL method and we got a quadratic trinomial like this one, the middle number, the middlemost number in my trinomial that's attached to the x is really this number plus that number. 4 plus 2 is 6. 5 plus 8 makes 13, and a positive 2 plus a negative 3 makes a negative 1. Okay, negative 1k in that last one. So the middle number is these two numbers added together. Okay, and I want you to notice also that this last number is this number multiplied by that number. 4 times 2 is 8. 5 times 8 is 40, and 2 times a negative 3 makes a negative 6. Okay? So that, you guys, is true all the time. When we have a FOIL method or double distributive property that looks like this, x and something, okay, linear guys like that. Okay, it's always this number plus this number is the middle, this number times this number is the end. That's how we're going to start doing our factoring, okay, our unmultiplying, our unfoiling of things. So if we take, for example, let's say we take x squared plus 10x plus 21. Okay, we've got this quadratic trinomial, right? X squared piece, quadratic trinomial, 3 pieces. When there's not a number in front of x squared, and we want to factor this polynomial into two sets of parentheses, okay, like this, it's always going to be x and then something, x and then something, all right? Now, the way we figure out what these two numbers are is we ask ourselves two questions. Okay, question number 1. What adds to 10? Why did I pick 10? Because that's the middle number. What adds to 10 and multiplies to 21? Okay, so this is the two questions, or really it's like a two-part single question. What adds up to 10 and multiplies to be 21? And what I mean by that is, what two numbers, when I add them together, do I get 10? And when I multiply those same two numbers, I get 21. Okay? So what we should first think about is, what are the factors of 21? Okay, that's why I had you do that IXL practice yesterday. what are pairs of numbers that together can multiply to make 21? Because I know that whatever these two numbers are, they have to multiply to make 21. Well, some options would be 1 and 21. If I add those together, do I get 10? No. 3 and 7, if I add those together, do I get 10? Yeah, I do. So these are the two numbers that I'm looking for, 3 and 7. So, to make a positive, they both have to be positive. So I'm going to go plus 3 and plus 7, okay? So these two linear binomials in parentheses are the factored form of this polynomial, okay? We factored it back into what we would have FOILed out or what we would have used the double distributive property on, right? And an excellent way to always check your answer when you get your factored form, your set of two parentheses, best way to check your answer is to just go ahead and do the double distributive property or do the FOIL method. X times X is going to make X squared. X times 7 is going to make 7X. 3 times X is going to make 3X. 3 times 7 is going to make 21. If I add all of these things together, the two middle pieces become 10X. And of course, I am at what I had. So I got the right factored form. I got the right two numbers, okay? Let's look at another example. What if I do X squared plus 14X plus 48. Okay, X squared plus 14X plus 48. Again, I'm trying to ask myself a couple questions, right? What multiplies to make 48 and adds up to make 14? Now, there's two ways we can go about this. We can either start listing out factors of 48, see if we can find two that add up to 14. Perfectly fine. That's the way we did the last problem. Or we can look at what two numbers can add up to be 14, right? What two numbers could add up to be 14? Well, my first option, I suppose, would be 1 and 13. If I do 1 times 13, do I get 48? Nope, I don't. I get 13. What about 2 plus 12? That would also make 14. 2 plus 12. 2 times 12. Is that 48? No, that's 24. What about 3 and 11? 3 plus 11 would make 14. What's 3 times 11? That's 33. Okay, so I'm still looking for 48. How about 4 and 10? 4 plus 10 is 14, but 4 times 10 is 40. How about 5 and 9? 5 plus 9 is 14. 5 times 9, that was only 45. But we're getting closer. How about 6 and 8? 6 plus 8 is 14. And what's 6 times 8? Oh, it's 48. So here's my two numbers, okay? 6 and 8 are the two numbers that I was looking for. So when I factor this polynomial, it's going to say x plus 6 times x plus 8, okay? This is the factored form of this polynomial. And again, I could double check it with the double distributive property if I want to or need to. In this case, I'm not going to do that. All right, so this is the type of questions we're going to be trying to ask ourselves to figure out what numbers go in these spots to make my factored form, okay? Now, this does get slightly trickier if we have a polynomial that has some negative signs. Okay, so let's look at an example like this. Let's go x squared plus 3x minus x squared plus 3x minus 28. Okay, x squared plus 3x minus 28. So now I want you to realize what it is that we're asking ourselves, right? I'm asking myself, what two numbers can multiply to make negative 28? Okay, so to multiply to make a negative 28, I'm going to need one of my numbers to be negative, right? A negative times a positive would give me a negative answer. So I need one positive and one negative. which already indicates to me that when I get my parentheses, when this last number is a negative, you guys, if it's a minus, it's going to have to be x plus something and then x minus something, okay? It's going to be x plus something and x minus something. So this is what my answers are going to look like. And now I know also that these two numbers, one positive, one negative, they have to add together to make a positive 3. Okay, they have to add to make a positive. If they're going to add together to make a positive, and one's positive, one's negative, this tells me that the bigger number is positive, okay? The bigger number is whatever this symbol is, okay? The bigger number is whatever that symbol is. So now I'm going to ask myself the questions, not so much in the positive and negative, but what numbers could multiply together to make 28? Okay, what numbers could multiply to make 28? Well, 1 and 28, but whichever one of those I make negative, they're not going to add up to 3, right? I could also have 2 and 14. Negative 2 and 14, those would add up to 12, so that's not going to work. I could have 4 and 7. Now, could those add up to 3 if one of them was negative? Those add up to 3 if one of them was negative. Well, let's just try it. Let's try negative 7 plus 4. Oh, but remember I said the bigger number was supposed to be the positive one. So let's try negative 4 plus 7. Does that equal 3? Yes, it does. Does negative 4 times 7 equal negative 28? Yes, it does. So there's my two numbers, okay? In negative 4, positive 7. So wherever the plus sign is, I will put the 7 because that's the positive one. And wherever the minus sign is, I'll put the 4. Okay, and this then is my factored form, right? So you can see how the questions we ask get a little more complicated when we have a negative sign, okay? Let's do another example of that one. If I have, let's say, I'll just spice it up a little bit. I'll go k squared minus 5k minus 14. No, 24. There we go. Okay, so we'll do this one now. K squared, I'll get the squared in here. K squared minus 5k minus 24. Again, I want you to notice my last number is a negative, so I know I'm going to have one positive, one negative. When I factor this out, when I make my factored form, there's going to be k plus something, and there's going to be k minus something. Okay, that's going to be my factored form right there. K plus something, k minus something. I also know from this piece, right, that's what they need to add up to. Because they need to add up to be a negative, the bigger number needs to be the minus one, okay? The bigger number needs to be the negative in this case. So now I'm just going to think about, okay, what numbers can multiply to make 24? What numbers can multiply to make 24? Well, 1 times 24 would make 24, but I don't think those are going to add up to 5. 2 times 12 would make 24. But again, I don't think either one of those being negative. Well, if it was negative 12 and positive 2, that would be negative 10. That's not going to work. What if I had 3, right? 3 times 8 could make 24. 3 times 8. Well, if I made the 8 negative, because that's the bigger one, negative 8 plus 3, does that equal negative 5? Yeah, it does. So there's my two numbers, negative 8, positive 3, because negative 8 times positive 3 is going to be negative 24. Negative 8 plus 3 is going to be my negative 5. So again, just asking myself what multiplies to be this, what adds up to be that. I came up with a positive 3 and a negative 8. Okay, so again, this is the factored form that I'm looking for. The unfoiled form, if you will. I unfoiled it, I undistributed it. All right, one more example and then we'll be done. The last example is when we have something like this. Let's say n squared minus 12n plus 27. Okay, so I have this now. N squared minus 12n plus 27. Okay, so what I need you to notice now is I'm back to having a positive at the end here. So we would think that both of my numbers are going to be pluses, n plus this and n plus that. The problem is these two numbers that I'm looking for to make my factored form are supposed to add up to negative 12, add up to be a negative. How are they going to add up to be a negative but multiply to be a positive? Well, when we see this number being negative, adding up to a negative but multiplying to a positive, we need both numbers to be negative. Okay? We need both numbers to be negative. Because a negative multiplied by another negative is a positive, right? A negative 5 times a negative 4 makes positive 20. Negative times negative makes positive. But if I add two negatives together, that becomes more negative. So when we see a minus sign first and then a plus sign, we know that both of our pieces are going to be n minus something and n minus something, okay? So this is what my factored form is going to look like now, n minus something, n minus something. Again, I'm asking myself, what can multiply to 27? What can multiply to 27? Well, 1 and 27, but if I made both of those negative, they'd add up to negative 28. So that's not going to work. 2 doesn't work. 3 times 9 would work. 3 times 9. 3 times 9. If both of those were negative, if I had a negative 3 and I added a negative 9, what would I get? Negative 3, negative 9, they add up to negative 12. Okay, so these are the two numbers I want right here. I want a negative 3 and I want a negative 9. So both of them are minus. One is a 3, one is a 9. And again, if we needed to check our factored form, you can always do the FOIL method or double distributive property. Okay? If you have questions about how we are factoring these quadratic trinomials, it is important to remember this only works the way we're doing it if there's no number in front of the squared part. But if you have questions, please reach out to me at some point. Email, phone, video, Zoom, office hours are all available for you. Otherwise, that's all I have for you today, and we'll talk to you soon.